Welcome back, Math 30-1. In today's lesson, we're going to look at using trig identities to solve trig equations. Okay, so let's take a look at the very first question, example number 1. It says solve the following question between 0 and 2 pi. So we know we're looking at a domain between 0 and 2 pi. That means we're looking at radians. So my first question here is we have 2 cosine squared of x plus 3 sine of x is equal to 0. Now when I look at this looks very complicated at first. So we have a square there. It kind of looks like a quadratic. So I'm going to make it a quadratic. And I'm going to put this cosine squared x into sine squared x. So if I rearrange this equation here, all I'm going to do is move the sine x to this side. So it's 1 subtract sine x squared is cosine squared. So we have 2. I'm going to put 1 subtract sine squared x, and then we want to plus 3 sine x. And we're saying that's equal to 0. Okay? Multiplying my 2, I'm going to end up getting 2 minus 2 sine squared x, and we have plus 3 sine x is equal to 0. So now I'm just going to rearrange this. So I have negative 2 sine squared x, and we have plus 3 sine x plus 2 is equal to 0. And now this could be factored. So I'm just going to quickly use my box method here. So I'm going to go, we get negative 4, and I'm going to have 3, so that's going to be negative 4 and 1. Okay? So I'm going to end up getting here the same as sine x, so sine minus 2, sine x minus 2, and we're going to end up getting my other one is going to be 2 sine x, and we're going to plus 1. Okay? That's equal to 0. Now I look at this here, we know then that sine x is equal to 2, and my other case is sine x, to solve for sine x here, is equal to negative 1 over 2. Now looking at this here, sine x cannot equal to 2, so there's no solutions on this half. Now for this one here, well, I know my reference angle for this one is going to be, if we look at this here, it's going to be, that's the short sine 1 over 2, so it's going to be pi over 6. We're in radians, so it's pi over 6 or 30 degrees, but we're in radians, we're putting pi over 6. Now, we know it's negative, so it's got to be in this quadrant or this quadrant. Okay, so it's in quadrant 3 or 4. So my answer is going to be x is equal to, we have to go plus pi over 6, so pi plus pi over 6. And my other one is going to be 2 pi minus pi over 6. So that's going to give me my answers of x can be equal to 5 pi over 6, 7 pi over 6, and we have 11 pi over 6 are my solutions. Okay, so now let's take a look at B. Here I have cosine of all of x plus pi over 6, subtract cosine of x minus pi over 6 is equal to 1. Well, this is my sum or sum of angles identity. So I'm going to look here. We have cosine. We're going cosine plus, so I'm going to be using this one. And I'm going to be using this one here. Okay? So I'm going to be using both of those. So first for the plus one, that is the same as cosine x multiplied by cosine pi over 6. And then we're going to subtract, because it's plus, sine x sine pi over 6. Okay? Now this is also, then we're going to subtract. I'm going to use my sum or difference identities for this one here. So we're going to have cos x, cos pi over 6, cosine pi over 6, and we are going to add, it's going to be sine x sine pi over 6. And this is all equal to 1. Okay? Now, once I put these in together, I can start canceling off because we're going cosine x cosine pi over 6, and then we want to subtract that. So those are going to cancel off nicely. Now I have negative sine x sine pi over 6, and then we're going to subtract a positive sine x sine pi over 6. So that's going to give me minus 2 sine x sine pi over 6, and that's equal to 1. So now I only have sines. So now I only have sines. So this makes it a bit easier. And I know sine pi over 6 is the same thing as 30 degrees, so that's going to be 1 over 2, that's my short sine. So I have negative 2 sine x, and then we have 1 over 2 is equal to 1. Now 1 over 2 times that is going to be negative sine x is equal to 1. So sine x is equal to negative 1. Now looking at this here, quickly do this. We want negative 1. That's only going to be right here. That's my max y value. And so we have pi, or 3 pi over 2 is going to be my value for x. And that's solved. Okay? Now let's take a look at class example number 2. It says, consider the equation 4 minus sine x is equal to cosine of 2x. Which of the three identities for cosine 2x would be the most efficient? So I look at this, I have sine x already on this side. Now, I look at my identities for my double angle identities for cosine. They're all right here. So first one, if I replace with cosine squared sine squared, that's not really going to help here because I already have sine. And it's just giving us more cosine squared problems. So here we have cosine squared minus 1. That's not going to help. Now sine squared, or 1 minus 2 sine squared, that could help because then everything's in terms of sine and I can make it a quadratic equation. So we're going to replace cos 2x, and we're going to use that with 1 subtract 2 sine squared x. Okay? So now it says determine the general solution. So I want 4 subtract 7 sine x is equal to 1 subtract 2 sine squared x. Just put in the identity that we used above. Alright? So now let's make this into our nice little quadratic equation. So I'm going to move everything on this side over, on my right hand side over to my left. So I'm going to get sine 2 sine squared x minus 7 sine x. And then I'm going to, so that's minus 1, so that's going to be plus 3 is equal to 0. Now I look at this, I can start factoring that, so I'm going to just use my little box method here quickly. So I'm going to have 2 times 3 is 6, and we have negative 7, so both are going to be negative. That's going to be 1 and 6. Okay? And 6 could be divided by 2, so that's going to be sine x plus 3. Oops, these are both negative, so that's minus 3, plus 3, so that's negative 3. And I'm going to have sine x minus 1. Okay? So we continue this here. I get 0. We have my two sides. Sine x is equal to 3. This cannot work. And my other one is sine x is equal to 1. Well, this one here, we can make that work. When is sine x equal to 1? Well, that's going to be both at pi over 2 and 3 pi over 2, because that's when my y is the biggest. So my answers here is x is equal to pi over 2 and 3 pi over 2. Oops. So now for b, it wants us to determine the general solution of our equation. Well, we already used the double identity and said we want 1 minus 2 sine squared x to be cos 2x. So I'm going to plug that in now. So I'm going to get 4 subtract 7 sine x is equal to 1 minus 2 sine squared x. Now I'm going to move all of this over to this side. I'm going to move my right-hand side to my left-hand side so I get a nice quadratic equation that's equal to 0. So it's going to give me 2 sine squared x, and I'm going to be minus 7 sine x, and we are subtracting 1, so it's going to be plus 3. Okay? It's equal to 0. Now we must factor this, so I'm going to use my trusty little box method here. So I have 6, negative 7, and we look at that there. I'm going to have negative 6 and negative 1. So that's going to be negative 6 divided by 2 is 3 over 1, and negative 1 over 2. So we have sine x minus 3, and we're going to have 2 sine x minus 1 for our possible roots, okay, or our factors. Now, we look at this more. I have, separate this, sine x is equal to 3. This cannot work, okay? Now let's take a look at the other one. I'm going to have sine x is equal to 1 over 2. Okay, so 1 over 2, and it's positive, so let's take a look here at my trig circle. 1 over 2, that's short sine, so that's going to be over there, and we know it's positive, so we could also have here. So my reference angle is equal to 1 over 2 is the short one, so it's going to be pi over 6 radians. And we also have then one more, so my x is equal to, we could also take pi, and we're pi over 6 short, so it's going to be pi over 6, and pi subtract pi over 6 is 5 pi over 6. But we want the general solution, so that's going to be pi over 6 plus 2 n pi, and we have pi, 5 pi over 6 plus 2 n pi, because those are going to be my periods, and we're looking at n is an element of all integers. Okay? Alright, so now let's take a look at question number 3. So here we have an equation. We have f of x and g of x between 0 and 2 pi. Okay? So write an equation which has a solution provided by the x-intercepts of the graph. So the solution of the x-intercepts is when g of x and f of x are equal to 0. Okay, so when we multiply them and they equal to 0, that's going to give me all of my roots or all of my x-intercepts of the graph. Second part says, write an equation which has a solution provided by the x-coordinates of the intersection points of the two graphs. So we want to know the x-coordinates of when the graphs intersect. So in this case here, we could write it in two ways. It could be when g of x is equal to f of x, right? Because that's when these two graphs are equal, they'll intersect. Or in other words, we could put g of x subtract f of x, or f of x subtract g of x is equal to 0. Okay? Because if we subtract these, that will give 0 because they're the exact same thing. Okay, let's take a look at C now. Okay, now, so for C it says the graphs on the previous page represent the functions f of x is equal to 3 sine squared x minus 2 and g of x is equal to negative cos 2x. So we're going to start off here. It wants us to use the graphing calculator to determine the exact roots of the equation. What's kind of nice here, it tells us exactly what our thing is. Now, if we want to find the roots, we found out from the question from on the page before that when we subtract them, we're finding the root. So basically here we have f of x subtract g of x. That's essentially what's happening here. We're going f of x subtract g of x, and that's to find us when they are equal. So in this case, find the roots is finding when they are equal. Okay? So this is f of x, subtract g of x. And we're saying it's equal to 0. So we're finding there when the two graphs intersect. Now, if I'm to graph that, I'm just going to do this quickly in my graphing calculator. I'm going to end up having 3 sine x squared, squared, and then we're going to go plus cos 2x, and then we want to subtract 2, and we have my window is between 0 and 2 pi, and then I'm going to graph, and it looks something like this. Okay? So we want to find the roots. We have 2 roots here. And if we do, we're going to calculate and we find our zeros. We're going to end up getting, I'll just do 1 here. Enter on the other side quickly. We're going to end up getting 3 pi over 2. So we have 3 pi over 2 for one. And if you do the other one, you're going to get pi over 2. Okay? So those are my 2 roots. Now, part 2, if I look at this, it is g of x multiplied by f of x. And if we go back from our last page here, g of x multiplied by f of x was the same thing as finding the x-intercepts. So we're at essentially finding the x-intercepts of the graph. So I'm going to plug that in here. And I'm just going to find a couple of them for you here. So I'm going to put negative cos, and I want 2x, and we want to multiply that by 3 sine, and we have x squared, and we want to minus 2. And we graph it, and this graph looks something like this. Okay. So now, if I zoom in here, I'll notice something. It hits twice because we had 2 that were very close to each other on our graphs before here. If I look at this right here, I have 2 that are very, very close together. So that most likely means I'm going to have 2 there that are very close together. So I'm going to go so I can calculate my, I'm going to first zoom, and I'm going to go at 1. I'm going to zoom in to one of these points here, right there. Okay, so now we're going to calculate it. And I have 2 intersections there. So if we calculate my intersections, and I want to find my 0, let's calculate 1. I'm going to go here, right bound. I'm going to get, that's the same thing as pi over 4. Okay, and then if we calculate the other one, it's going to be 0.95. So I'm going to get pi over 4. And then we want all the way between 0 and 2 pi. The next one is going to be 3 pi over 4. Then we're going to get 5 pi over 4. And then 7 pi over 4. So that is for one of the graphs. Now the x-intercepts for the other graphs are going to be including that one there, which is going to be 1. And then we're going to have 2.2. Then we're going to have 4.1. And then 5.3. So it wants us to verify the roots algebraically. So we're going to start with our first one equation here. So we want to put, we have 3 sine squared x plus cos 2x, cosine 2x minus 2 is equal to 0. Okay? So I look at this here. I want this, we're going to use the double angle identity for sine, so I keep everything in terms of sine. So this is going to be the same as 3 sine squared x, and we're using double angle identity with the sine for cosine plus, and we're going to have 1 minus sine, 2 sine, squared x, and we minus 2, and that's equal to 0. So now I'm going to simplify this out here. So 3 sine minus 2 sine gives me sine squared x, and we have plus 1 minus 2 minus 1 is equal to 0. Now I look at this. This makes a perfect difference of squares, so this is nice and easy to solve. So I'm going to have sine x is equal, or sine x minus 1 multiplied by sine of x plus 1. And that's equal to 0. So we have sine x is equal to 1 and sine x is equal to negative 1. So I look at this here. 1 and negative 1, quickly draw it out. Negative 1 is 3 pi over 2, and 1 is pi over 2. So we have over 2 and 3 pi over 2, which is the exact same answers we got there. Alright, let's take a look at my second part here, which is finding the x-intercepts. So let's write down our equation. We're going to prove it. So we're going to have negative, or we're going to solve it. So we're going to have negative cosine 2x multiplied by 3 sine squared x minus 2, and that's equal to 0. Okay? Now once again here we have two equations, and I could substitute, but I'm not going to because it's in a multiplication statement. So I'm going to separate this right now, and I know cosine of 2x is equal to 0. I just put the negative on this side, so negative 0 is still 0. Okay? On my other side, I'm going to get 3 sine squared x is equal to 2. So sine squared x is equal to 2 over 3. Okay? So let's first look at the cosine x. So it's a double angle. So right now, we're going to look at my period because of the 2. It's going to be between 0 and 4 pi. Okay? For this one here. Because really, we are compressing it, so there's double the amount in there. So for when we go, and we want to find the values of x, so we want 2x is equal to, I'll make some more room. Okay, so 2x is equal to, let's take a look here. When is x equal to 0? Well, that's going to be right here at pi over 2 and 3 pi over 2. Okay, so those are my two solutions. So we have, and we're going all the way to 4 pi, so we have pi over 2, we have 3 pi over 2, and then if we go another 360 rounds, so we add 2 pi to this, that's going to give me 5 pi over 2, and we're going to have 7 pi over 2 for my other answer. Now, that's the same as 2x, but we want just x. So I'm going to divide everything by 2. So I'm going to get x is equal to the same thing as pi over 4. And I'm going to get 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay? Now let's take a look at my sine side here for my x values. So what I'm going to do is we must square root both sides. So I know sine x is equal to square root of 2 over 3. So I'm going to just put that in my calculator now to figure out what that is, since that's none of our identities. So we're going to go second sine, and I want the square root of 2 divided by 3, which gives me 0.955, which was the same as what we got there. Okay? So if we're looking at that, and we know sine here, sine squared, so that means it could be in all quadrants. So if it was sine squared, it doesn't matter, it could have been plus or minus this. So we're looking at all 4 quadrants. And my reference is equal to 1, or 0.9555. So then I'm going to have to go 3 pi, let's take a look here. So now, or 0. I'm going to put 955. So then we have x is equal to 0.955, and then we're going to have pi minus 0.955. Then we're going to have pi plus, for this one here, 0.955. And then we're going to have the last one here, quadrant 4, 2 pi, subtract 0.955. Okay? So all of my solutions here are the combination of this and this, which ends up giving me the the exact same thing as what I got above here.